How much did you score in class 10 maths? Did you like the subject?
Yes, sir. 7 reports.
Okay. And you are preparing for any exams?
J, sir.
J. So how was your boards? All good?
Yes, sir, was good.
Okay. Okay. So first of all, remember this class 10th and class 11, 12th. There is a big jump, right, in maths. So most of the students, what they feel is demotivated. So do not worry about anything like that. Just focus on few topics. All right. Trigonometry. When we do this in class, remember, memorize all the formulas. Right. Even if you do not understand the chapter, just memorize the formulas. All right.
Yes, sir.
Second is calculus. That is limits, derivatives, relation function. If you just do these 4 chapters very, very, very thoroughly, then your whole 11th and 12th will be going great. All right. This thing
Yes,
is
sir.
clear. All right. Second thing, never hesitate to ask any doubt. All right. This class is for you, right? We are here for you, right?
Yes, sir.
Okay. So no need to be shy or anything, and be communicative, right? If you keep silent, I would not be able to know if you understood or not, right? Okay. So let's start our first chapter, which is complex number. All right. The name suggests that this chapter is going to be complex, right? But not so, not so much. All right. Only the name is complex. Why so? Way back, all right, around 1400, 1500, few people were doing mathematics, right? Solving few questions. And they stumbled upon this equation. All right, x square plus 1 equals to 0. Right. We know what are equations since our previous classes, right? X plus y equals to 0, 2x minus 3 equals to 0, and so on. Right, Asha?
Yes, sir.
So if I have to solve this, I'll get x equals to 3 by 2.
Yes, sir.
So what this means, if I put the value of x as 3 by 2 here, the whole equation becomes 0. This is called the solution. Now the mathematician who stumbled upon this tried to find out what will be the solution of this equation. All right. So what he did is x square equals to minus 1. So x will be equals to under root minus 1. Right.
Yes, sir.
But how do we know, like, what is the square root of minus 1? If I ask, what is the under root of 4? What will you say?
2, sir.
2 or plus minus 2?
Plus minus 2.
Actually, the under root of 4 is 2. All right. Remember this. Under root always gives the positive value. But if I write x square equals to 4, then x can be plus minus 2. All right.
Yes, sir.
Okay. Now, if I ask you, if x is plus minus 2, that means 2 into 2 will get 4, minus 2 into minus 2 will get 4. So if the number is positive or negative, the multiplication, the square, will always give us positive numbers, right?
Yes, sir.
But here we are getting a negative number, right? I'm trying to find the square root. That means I have to find a number which, if we multiply 2 times, that should give us minus 1.
Yes, sir.
So can you think of any of that numbers? Suppose I give you x square equals to minus 4. Can you tell me if there is a number? which we multiply 2 times, that will give us -4?
No, sir.
No, right? Just as you, the mathematician who stumbled upon this could not find any answer to this. All right. He could not imagine a number where the square should give us -1. So what he did, he named this number x equals to under root -1 as iota with the symbol I. I means imaginary. It's clear?
Yes, sir.
Because he could not imagine. So anything we could not imagine, we say that is an imaginary thing, right? Like ghosts or anything like that. All right.
Yes, sir.
So any number which has a negative under root. So -4, can I say this is 4 into -1?
Yes, sir.
And this is under root 4 into under root -1.
Yes, sir.
So this is 2 and this is iota.
Yes, sir.
So this is again called imaginary number.
Okay,
Absolutely
sir.
clear?
Yes, sir.
Okay. So what you can do is please note it down. Imaginary numbers are numbers which are denoted as a iota, where a is a real number and iota is under root of -1. Right? A iota means 2 iota, 3 iota, 1/2 iota, anything like that.
Yes.
I believe this is absolutely clear.
Yes, sir.
Okay. So this is called imaginary number. But what chapter we are studying? Complex numbers. So why is this called complex number? Now, after some time, one mathematician came and said, all right, we have got real numbers, right? We have got imaginary numbers. What happens if we add them together? Suppose there is a real number 2 and there is an imaginary number 4 iota. So if I write there is a number x which is 2 plus 4 iota, this is a real number. This is a imaginary number. If we add them together or subtract them together, what we get is a complex number. Because things tend to get too complicated. We cannot imagine a number like that. All right.
Yes, sir.
This is also clear.
Yes, sir.
So please note it down.
So anything paired with iota would be a complex number?
Right. Any real number if paired with iota. All right.
Okay, sir.
And remember, this can be 0 also. Right. Because 0 is also a real number.
Okay, sir.
All right. So any complex number looks of the form x equals to a plus ib. All right. Where a and b are real numbers. Right? 2 and 4 are real numbers. But because 4 is paired with iota, that becomes complex. Clear?
Yes, sir.
Okay, so please note it down. Done?
1 minute, sir.
Okay.
Done, sir.
Okay. So real numbers we can deal, right? We have done since childhood, 2 plus 2, 2 into 2, everything. What is the new thing here? Iota. So let's get familiarity with iota. So what do we know about iota? Iota plus iota can be added together, just as in real number. All right. AI plus bi, we can say this is a plus b. All right.
Yes, sir.
And same with subtraction. Multiplication, division, we'll see further. Powers of iota. And this is very important. Most of the questions come from this, powers of iota. So we have got iota equals to -1 under root, right?
Yes, sir.
If I do iota times iota, so this becomes -1 under root square. So what does it become?
1.
1. Are you sure?
Yes, sir.
See, under root and square gets cancelled out. So what remains?
-1.
-1. Very good. Right. Just imagine like this. X is this. So x square will be -1.
Okay, sir.
So remember, this is I to the power 2. Now, can you tell me what will be I to the power 3?
I, sir.
I or minus I? I can write I cube as I square times I, right?
Yes, sir.
So I square is -1 and I is I, which is minus I. Clear?
Yes, sir.
Now, what will be I to the power 4?
I, sir.
Check again. So this we can write I square into I square.
Yes, sir.
And what is the value of I square?
-1.
So this becomes -1 into -1.
1, sir.
This thing is clear?
Yes, sir.
Okay. Tell me the value of I to the power 5.
Sir, I.
I. All right. And what is the value of I to the power 6?
I square, sir.
Sorry,
I square.
minus
Sir, I square.
I square, right? And what is the value of I square?
-1, sir.
-1. I to the power 7,
I, sir.
minus I. And I to the power 8,
1, sir.
I to the power 9,
I, sir.
I to the power 10,
I square. -1.
I to the power 11,
I, sir.
I to the power 12,
Minus 1, sir.
-1,
No, sir, only 1.
only 1. So do you see any pattern here?
Yes, sir.
What is the pattern?
I minus 1 minus I and 1.
Right. So what do I say? This is I minus 1 minus I1. I minus 1 minus I1. I minus 1 minus I1. So can I say the powers of I repeat after 4, right?
Yes, sir.
So can I say if there is any power of I, if I write it like this, I to the power 4 something plus n, then this becomes I to the power n,
Yes, sir.
right? Because I to the power 4 multiple of 4 anything becomes 1.
Yes, sir.
So if anyone asks you, first note it down, then I'll give you questions. All right, powers of I. All right, tell me when you're done.
Done, sir.
All right. So if anyone asks, what is the power of, what is the value of I to the power 100? All right. So always the first step is to break it down into multiples of 4. So can I say this is I times 4 times 25?
Yes, sir.
So this answer is,
25.
see, this is 4k, I to the power 4k. So can I say this is I to the power 4 to the power k?
Yes, sir.
And what is I to the power 4?
1.
So this answer is
1.
1. So remember this, if you have I to the power multiple of 4, then the answer is automatically 1. All right, if you have I to the power 4k, the answer is 1. If you have I to the power 4k plus 1, the answer would be I. All right, why
Yes.
so? Can I say this is I to the power 4k into I to the power 1? Power add together, right? If the base is same.
Yes, sir.
So this becomes 1 into I.
Yes,
If
sir.
you have I to the power 4k plus 2, this becomes I square, which is minus 1, right?
Yes, sir.
And I to the power 4k plus 3 would be,
Minus I.
and there is no other power possible, right? Because I to the power 4k plus 1 will be I to the power 4k plus 1. If you write I to the power 4k plus 4, So this I can write I to the power 4k plus 1. So this is the first gate itself,
Yes,
right?
sir.
All right. So please calculate few things. I to the power 125. See if you can solve this.
So 1.
But how do you solve this?
So I to the power 4 into 31.
Right.
This
So
one.
absolutely, we can divide by 4 and we'll get this 31 into 4 plus 1, right?
Yes, sir.
So I to the power 4 into 31 plus 1. So this is 4k plus 1, which is I. Very good. So I hope this is clear, right?
Yes, sir.
So few questions that you need to solve now. I to the power 135, I to the power 19, I to the power minus 999, I to the power, or we can say this is all right. Try to solve this. Tell me when you're done.
Done, sir.
Okay, what are the answers? Here I can say this is 132 plus 3, right?
Yes, sir.
So this is a multiple of 4. So that becomes 1 I to the power 3s minus I. All right.
Yes, sir.
And this is 16 plus 3 again. So this is minus I.
Yes, sir.
And this is I to the power, first we can say this is 999 to the power minus 1. All right.
Yes, sir.
So this is I to the power, I can say 996 plus 3 to the power minus 1.
Yes, sir.
So this becomes 1 I cube is minus I to the power minus 1.
Yes,
All
sir.
right. So how do we simplify this?
So I.
Okay, how we know this is I? See, this we can say this is minus I or 1 upon minus I,
Yes, sir.
right? Remember, whenever you have negative power, always take that into denominator. All right. So
Yes, sir.
minus I took that into denominator. Now, can I multiply this with I and I like this?
Yes, sir.
So the numerator is minus I, the denominator is minus 1. So the answer is I. Okay.
Yes, sir.
So whenever you have negative power, always take that into denominator, then solve. Otherwise, you might get it wrong.
Okay, sir.
And this is minus I to the power 4n plus 3. So I can say this is minus 1 into I to the power 4n plus 3. So minus 1 to the power 4n plus 3, I to the power 4n plus 3. Yes or no?
Yes, sir.
So this is minus 1 to the power odd number, right? 4n is even plus odd is odd.
Yes, sir.
So minus 1 and this is minus I. So I hope all of this is clear.
Yes, sir.
Okay. Next type of questions, what you will face, they will not give you questions like this directly. What they will say is find the value of I plus 1 upon I. So what you can do, you can normally take LCM also, or first you can simplify this just as we did in the previous question, then add together. All
Yes,
right.
sir.
Or you can take directly the LCM. This becomes I square plus 1 upon I. I square is minus 1 plus 1 upon I, which is 0. All right.
Yes, sir.
So solve few questions, note it down, then solve few questions. I to the power, this is just a minute. I to the power 17 minus 1 upon I to the power 34 whole to the power 2. Find the value of this. All right.
Yes, sir.
solve this? Risha?
Answer.
Okay. So the first part, we can say this is I to the power 16 plus 1, right? So
Yes, sir.
I, and this is, if I multiply I in the numerator and denominator, this becomes I to the power 34, right?
Yes, sir.
And that is I square, which is minus 1. So this becomes I plus 1 to the power 2. Now a plus b whole square we know. So
Yes,
I
sir.
square plus 1 plus 2i. So this is 0. The answer is 2i.
Yes, sir.
And the second part, have you solved this?
Sir, 0.
0. Very good. All right. So no need for me to solve this.
No, sir.
Okay. All right. Now there is a theorem, a very short theorem. All right. The theorem says under root a times under root b is equals to under root ab only when a and b both are or not true, only when both are negative. Right? Write it down, then I'll explain what this means.
Answer.
All right, done.
Yes, sir.
Okay. So what this theorem says, if I ask you what is the value of this under root 4 and under root 16, what will you say? What is the answer here?
8, sir.
8. Very easy. What you did this under root 64, which is 8. All right. This we can write as this, no problem. But if I give you under root minus 4, under root minus 16, what there is saying is this you cannot write. Not true when A and B both are negative. So here we can see this and this both are negative. So we cannot say this is not equals to under root minus 4 under root minus 16. So 64. We cannot write like this. Never cancel minus minus plus. All right.
Yes, sir.
So how we can solve this? This will be 4 times minus 1 under root into 16 minus 1. So I can say this is 2 iota and this is 4 iota. So this is 8 I square, which is minus 8. All right.
Yes, sir.
Please note it down.
Answer.
All right. Solve few questions. And remember, this is only true when both are negative. Otherwise, you can just take iota and you will get the answer. Solve few questions.
So if one is negative and the other is positive, then we can do it
No
as
issues.
the normal way.
If like this, minus 16 and 4. So this is 16 iota, under root 16 iota into 2. So this is 4 into 2 iota, which is 8 iota. All right.
Yes, sir.
So solve few questions. You have to simplify this. All right. Tell me when you're done.
So in the second question is the root for the whole fraction.
Second question. First question is clear.
So can you repeat?
First question is clear.
No, sir. The second question is the root for the whole fraction.
We'll do it. Root 24. How?
No, sir. Like, is the root for the whole fraction in the second term?
Okay, okay. You are asking the question. Yes, this root is for whole fraction.
Okay, sir. Done, sir.
All right. So this is 12 iota, right?
Yes, sir.
And this is
-3, sir.
minus 3. And this is 5 iota plus 6 iota plus 6 iota, right?
So I got 12 and 18.
How? See, this I can say this is 25 under root into iota plus this is 3 into under root 4 iota plus 2 into under root 9 iota.
Yes, sir.
So under root 25 is 5, under root 4 is 2, 2 into 3 is 6, under root 9 is 3, 3 into 2 is 6.
Okay, sir. So in the first one, can we write 12 I as 12?
First one you want to write it as?
So 12.
No, this will be 12 iota, right? We have a negative sign,
Okay, sir.
right? Under root of any negative number is always imaginary. So you cannot make it a real number.
Okay, sir.
Got it?
Yes, sir.
Okay. So everything about iota is clear to us. Now let's again go to complex numbers. We saw complex number looks like this: a plus ib. All right. In this is called real part, and this is called imaginary part. And remember, real part is a, imaginary part is b only, not ib. All right. If you say imaginary part of a complex number x, then that automatically means this b will come with I. Is it clear what I said?
Yes, sir.
Complex number generally is denoted by z. Z is 3 plus 4i. So can you tell me what will be the real part of z here?
3,
And imaginary part?
4.
Very good. All right.
Yes, sir.
Real part and imaginary part. You have to tell me.
So -5 is real and -2 is imaginary.
Absolutely correct. No doubts in this.
No, sir.
Real part and imaginary part.
2 is real and -3 is imaginary.
Very good. Okay. So what is purely imaginary, purely real, or purely imaginary complex number? All right. Purely real. If a complex number z is purely real, then imaginary part of z will be 0. Very important. All right. If z is a complex number where a plus ib, and we say z is purely real, so what we can say, b equals to 0. Clear?
Yes, sir.
Okay. Same way, if it is purely imaginary, if z is purely imaginary, then the real part of z is 0, which means if z equals to a plus ib, then a equals to 0. Please note it down.
Answer.
Okay. So everything we did today is clear, Harsha?
Yes, sir.
Okay, we understood what is iota, what is imaginary numbers, what is complex numbers, powers of iota, right? And did a lot of questions. Everything is clear,
Yes, sir.
and you have noted down everything.
Yes, sir.
All right. For the next